Hello everyone, my name is Jeremy Brown and this is my presentation Summer Fuzz, Fuzzing macOS. Quick run through of the agenda, do a quick intro, walk through some of the different debugging tools, talk about SIP and App Sandbox, how that affects fuzzing, talk about crash reporting, what to do for machine sleeps and SSH types issues, how to monitor process execution, enumerate handlers, different file handlers, and things like that on the system for attack surface, and look at some of the clients and network services enumeration as well. And then we'll get into the fuzzing. So fuzzing command line apps, fuzzing GUI apps, fuzzing network clients, the servers, and some of the bugs from that, and then wrap up with a conclusion. So who am I? Mostly interested in bug hunting, fuzzing, offensive security stuff. Worked at a few different companies before doing that. Really like breaking stuff these days, different native code, web services, cloud, containers type attacks. Getting in good shape before release has been a lot of what I've been doing. So before getting into Mac fuzzing, I didn't know much about Mac security. Macs were, I didn't use one on a day-to-day basis for a long time until recently, maybe the last year or so, and I didn't know much about how to do debugging and things like that. So a lot of this stuff was new to me, so I was sort of learning as I was, getting more information about it. But I've been fuzzing for a while now. And there's a lot of advances these days with AFL++, and really doing state-of-the-art fuzzing built up on AFL. But I want to look at it at a different angle. Honestly, I just forgot a lot of what I knew and what was conventional wisdom and things like that. And I wanted to build something from scratch that really served a purpose for what I was looking for. So that's what we'll be talking about today, just the various tricks and going over some of the tooling for fuzzing userland specifically on Mac. So be mostly looking at the core, like the default applications on OS X and OS X 11, which are pretty similar. And looking at the client and GUI apps, network apps, things like that. Essentially, what I want you to take away from this presentation is how to set up debugging, how to enumerate targets, how to make vuln research easier. This is not about, scaling fuzzing for a huge fuzzing farm, and a lot of the stuff you can do with just a Mac at home. A lot of the prior work that is related or relevant is some of the Nagy stuff. It's pretty great. Crash Wrangler, and then the temp out sh zine, which was a little bit of inspiration to get back in fuzzing. So for debugging, Xcode and Xcode tools, you can, there's a headless script that I've referenced down there to install that. And you can enable developer mode as well to make sure that you can perform various debugging operations. As far as debugging goes, guard malloc is something good to turn on when you're fuzzing. Essentially, you can get free bugs from inserting this malloc helper library that can help find more of the subtle bugs when fuzzing. Maybe you wouldn't find without the extra helper stuff in it. So you can read more about how it works, but there's different things in different platforms as far as malloc helpers go and heap debugging goes, but guard malloc is something good to turn on when you're fuzzing, and this is you can do it with the dyld insert libraries variable. For LLDB, you can automate a lot of the crash triage and bucketing stuff just by passing command line args. It's really flexible for a lot of different things. This is how you can get, when you're fuzzing and you want to get automatic, you want to produce logs of, doing triage and things like that. You can easily do that with LLDB. SIP is a very important one to know about when doing research for fuzzing and debugging and stuff like that. A lot of times you either want to turn it off completely or disable it. disable certain parts of it, because otherwise you're not going to get too far running the debugger headless, for example. On a physical machine, you can just reboot into recovery mode, use CSR util to disable it completely, or just turn on debug stuff. If you're using VMware Fusion, which I recommend for a lot of research, because of course, VMs are great for snapshotting and taking snapshots of different states and replaying things. You can do that. It's a little different between OS X and OS 11. So this is OS X 10, and then for OS X 11, there's a little more trickery involved, but you can still get it done. The app sandbox is another thing to consider when fuzzing. Again, you can read more about it. It's not a talk about the sandbox itself, but it does get in the way sometimes, and you need to be aware of certain things, where to put files and things like that, to make sure the sandbox doesn't prevent you from getting coverage on targets. For example, say you mutated files and put them in temp, and then your target takes files as a command line to open, whatever it is, PDFs or things like that. So if you try to do that with certain targets, it won't work. It'll say, you're not allowed to open it, or don't have permission, or things like that. And if you check the logs, you can see the sandbox is kicking in, and it doesn't like where the file is coming from. So you need to find another place to put test cases for if you run into some of those restrictions. There's different container app bundle directories for a lot of different apps on Mac, and you can browse that directory and see the different ones. For example, for the Books app, you have com.apple.ibooksx and the data directory, which also has a temp directory inside of that. Of course, you can still double-click in an EPUB from wherever and open it in iBooks. But if you're going to be fuzzing from command line, you just need to be aware of where to put it so the sandbox doesn't block it. For crash reporting, most of the time, I would say it's okay to disable report crash, just because it's may get in the way of your triage program. And what it does, whenever there's a crash that happens, it creates a crash log and triggers a bunch of other stuff. But there's actually some ways to use it to your advantage, because for certain targets, maybe you're fuzzing something remotely and you don't have a good way to check for crashes, and you're not running it in a debugger or something. If you can run it in a debugger and attach to it, of course, you can create your own crash reports. But if you can't, you can actually leave report crash on, and then you can just monitor the diagnostic logs directory and just parse those for crashes and stuff like that. So it comes in pretty handy either way. Sleep, that's another problem I ran into, especially fuzzing on commodity hardware. If you're fuzzing on a MacBook Air and stuff like that, they are set up to be super eco-friendly. So that becomes a problem when you got remote fuzzing sessions running, but they're like, hey, let's go to sleep because that's going to save energy and hardware cycles and things like that. So you need to disable a lot of different sleep modes to make sure they don't get interrupted. There's different programs that can help you with that. I learned a lot about system administration with Macs, just trying to figure out, is there a way to make sure this thing never goes to sleep? And different systems are easier to work with than others. But especially if you're using SSH and you're doing remote sessions, which makes a lot of sense in a lot of ways. You can fuzz GUIs over SSH because they just pop up on the desktop and things like that, the way Mac is designed. You can also try sending some of the things built into fuzzers. You could do is just basically send control sequences to make sure that the session always thinks you're alive, and it doesn't have any reason to want to go to sleep. This is a battle. I'm pretty tired of fighting, but you can do that, and you can also mess with the SSH deconfig I tried a whole bunch of different configs just to try to figure this out, and this is the one I came across that was been fairly successful so far. So you can use the TCP keep alive. For monitoring process execution, if once you disable SIP and you have debug capabilities and privileges, you can use a handy dtrace script that's included on Mac called newproc.d. If you run that, it seems to be like this secret or something that this exists. It's really great for looking at what commands are being executed on the system. It's especially useful if you're looking at a back-end system like a web app that has a front end and is doing admin tasks. There's ways to find command execution, to get visibility to find command execution bugs like that. But for us, it's just interesting to see how things are being launched and what commands are being executed when we maybe flip on certain stuff or running different apps on the system. So if you run a command and you grep stuff you care about or stuff you don't care about, you can see what's going on as far as command execution goes on the system. Looking at the different handlers on the system, there's a pretty cool app called Swift Default Apps. There's a script SWDA that you can run to get the schemes, and that will give you the different URI handlers on the system. So you can see there's quite a bit, 101 when I ran this on a test box. And it maps each one. You can sort of get an idea of the attack surface as far as URI handlers go, and what you can execute on a system like that. As far as file handler goes, you can also get the UTIs, and you can map those to the different apps. So you can see, okay, as far as file formats go, what is the attack surface? We can get a pretty good picture of that. Quite a few of those, 420 different formats. Again, Mac is. Yeah, it is the multimedia world for sure. That doesn't necessarily tell you the file extensions though. For example, with AppleScript, you can see it's com AppleScript script. But then if you do some more research, you can figure out that that's actually .scpt file and things like that. So some of those you have to dig a little deeper into. Another way to look is just asking questions like what file types are included on the file system. Like what different files are they already exist. If those type of files exist by default, then there's probably a program that can read them in some way. And then you can just if you see stuff you don't know what it is, the different file extensions, you can Google for it, and can give you clues to what apps may be handling it. And did you know there's a Notepad equivalent program on Mac that parses doc and RTF files? So another interesting thing about looking at attack surface, you would think TextEdit just opens .txt files, which usually don't have a lot of attack surface because they're parsing text. But actually, it opens doc and RTF files, which are more complex formats and definitely increase attack surface. Another thing that's interesting I came across is some files are actually directories. So I was looking at the different file handlers on Mac, and I was looking to see, okay, for example, for a calendar app, there's a backup file, test.icpu format. If you double click it, it opens like a file. It opens the calendar app. Everything works fine. But if you look at it on the command line, it's actually a directory. And that makes fuzzing more difficult because if you go into it thinking, okay, everything I'm mutating as a file, you can do, file manipulation is pretty straightforward. But if you give it an input that is a directory that is being used as a file, that gets a little more complicated. So you're not just mutating a file, you're opening a directory, and then you got to figure out what the right files to modify are that are being parsed, because there's a whole bunch of different, the directory structure contains a lot of different files, some of which may be important, some of which may not. So it's another thing to consider when looking at fuzzing on different targets. And then enumerating network processes. There's, again, dtrace. It's pretty awesome. Comes in handy here. We can use different features of it to look at what processes are calling receive, which means they're taking data off the network essentially. So we can look at a receive log, let that run for a while, and then we can see what processes are actually parsing data, and that can give you an idea of the attack surface as well, as far as on the network side. And then you can just run a good old netstat. So if you just grep for listen, you can see a whole bunch of stuff running on different ports. And you can run LSOF, which is pretty nice as well. That can give you more process information and more protocol information about what's running. So, you can see different stuff running here. Cups daemon, screen share, launchd has some different listening services, KDC, all that stuff. So as far as fuzzing goes, AFL, it's if you try to run it on Mac, it's not going to work very well. That's a lot of the new development is on AFL++, and they've figured some of these different bugs out. And added a ton more features. Can't say enough good things about that project. They're really, continuing to push the state of the art for fuzzing and standardization on that. So that's great. But what about GUI apps? That can handle command line stuff. But if you try to fuzz font book, for example, with different fonts, it's not really meant for that. It's not designed. It's designed for things that exit quickly by default. Not so much for GUIs, which can stay open as long as you don't click X, right? And then network fuzzing, Windows stuff. There are different projects to try to handle that corner of fuzzing as well, but they have their limitations too. So LightFuzz, this is a project I've been working on that just works. That's the key thing. I wanted something that would I don't have to install different I don't have to install different tools and different fuzzers to fuzz on different platforms. I want to keep the same libraries. I just want to have something that I can, run a setup script or whatever, and it just works on Linux, Mac, and Windows. So that's what I created. It supports file network fuzzing, clients and GUIs. Even has some features to do network, interactive network apps like Postman and FileZilla and stuff like that. It has automatic crash triage and diffing. So once it comes across it, once it detects a crash, it will run a debug session. It will do diffing for the input file to show you exactly what changed, and a whole bunch of other artifacts. So it's most useful for fuzzing closed source applications. For example, if you wanted to fuzz a CLI that's open source, of course, you're going to be able to get coverage data and instrumentation if you just use FL++ to instrument it and things like that, if that's possible, if you don't run into issues with that. So this is more for it's kind of perfect for fuzzing Mac because most stuff in Mac is closed source, right? And it's really built for bug hunters. It's not I'll go over some of the trade-offs as well, but it does some pretty neat things in unorthodox fashions. But it breaks a lot of the rules of modern fuzzing. It doesn't do instrumentation. That was not a goal of the project. Again, AFL++ is great at that. Other frameworks are too. It's not meant for speed. Again, instrumentation is going to give you a lot of the speed and different kernel tricks as well, or OS tricks the AFL employs. Not meant for that. It is meant to cover a ton of different domains and work cross-platform. It doesn't have, not natively, DevOps integration where you can automatically file bugs and run in, every time there's a build and things like that. Things can certainly be built around that. But most importantly, it was built to find bugs. And that's exactly what it does. How do you know if Fuzzer's doing a good job? Does it find bugs or not? That's what we're going with today. So fuzzing some of the Mac intricacies, we talked about before the sandbox stuff. Some GUI apps, they like unique file names. That's another thing I ran into, which was if you try to reuse, temp/fuzz, for example, not all apps like that. They may bail if they literally don't see the right extension, or they've seen this file name again, so they try to cache it or try to refer to it back in some way. Again, reading within the sandbox, we talked about that. And some of them are just hard to fuzz directly. There's XPC proxy and XPC type stuff that comes into play, and some things just I feel like at Apple there was this traditional and this new app process that probably came out a while back. I'm just speculating that a lot of apps got converted to we're just not gonna let anyone pass commands, files as commands to them to fuzz. So I'm just dubbing that like the classic way, because there's still a ton of apps that work that way, but some apps do not. So future research is to look into some of the IPC stuff that happens with certain applications, because that could be interesting too. So for targeting applications, you basically pick a CLI, pick a GUI, collect the test files. If the target doesn't exit on its own, measure a reasonable timeout. Like we said, command line apps versus GUI apps, that's the biggest difference. A lot of command line apps will exit after they try to parse a file or do whatever operation. GUIs oftentimes do not. So measure a timeout, and then you can start fuzzing. So here's an example. Command line, if using light fuzz, where you're doing local fuzzing, or passing the command, which is the app, and then the fuzz placeholder, which just means put our fuzz file here, replace the word fuzz with our fuzz file internally for the fuzzer when every iteration. And our input directory is files and EPUB, which is just our input files, or EPUB input files in this case. You can select an output directory. We're going to be using a special temp directory instead of using the /temp /lightfuzz / its own directory for each session. You want to specify a special one to make sure that the application actually opens their file properly and doesn't complain. Max running timeout, again, 10 is pretty high, but that's on my test system, that's how long it took for the Books app to open this file. So if you have faster systems and things like that, that's going to be different. But just to give you an example, things not meant for speed. You're literally executing iterations one by one. Then the number of iterations, you can put any number you want there. I just used 100,000 for a reference, and we'll talk about easy in a moment. And then with FontBook, pretty similar. So easy, essentially the -e command is just a feature of LightFuzz that says recycle any of the crashes that you found. Make those as inputs once you're finished with the iterations that we're running. So in this example, after 500,000 iterations, it would say, okay, did I find any crashes? If so, copy those crashes to a new input directory. Use that input directory for a new fuzzing session for 500,000 iterations. So that way it's possible to find even new bugs, because you're recycling crashes to still mutate, and you could find potentially new bugs using that because of how crashes work and memory corruption, and mutating files that are different can trigger different kinds of crashes in different places in the app. So it's a neat little feature that's in the fuzzer. And then fuzzing package util, it's a CLI, so you don't need a max timeout for it. It just stops on its own after it exits on its own. With console apps and stuff like that, you can also use FL in non-instrumented mode on it too. So the primary purpose of LightFuzz is to handle situations that AFL can't handle, or I guess making AFL work on all platforms is pretty pretty good feature too, as far as purpose goes. But you could also fuzz command line stuff on Mac in non-instrumented mode with AFL as well. So FYI, but this is just an example to show you that LightFuzz can do it too. And you can also look at the output. So there's like a global output when fuzzing that is written, just so you can monitor the app, just make sure it's working correctly, make sure you got the command line args good. You can see with this one, we were fuzzing package util. It looks like it was fuzzing XML, and it mutated XML, and package util is complaining. So you can see that it is being fuzzed. Minimizing crashes is another interesting feature. So it's super simple the way it works. It literally just, when you want to minimize a crash, it just removes one byte at a time and runs the target with a new repro. If the target crashes, the new repro, the new minimized test case, if it crashes, then continue removing the bytes. So remove that byte and then go into the next one. If it doesn't crash, restore that byte, don't remove that byte, because apparently it's important because the target didn't crash once we removed it. So the point of minimization is to get the smallest possible crashing test case. Simple byte by byte minimization just goes one at a time, and then for Superman mode, which I've dubbed, it does that, but it repeats the process until all the bytes are exhausted. Rather than a single pass, it will go from the top bytes to the next one. It'll say, okay, let's take that one, minimize it again. Take that one, minimize it again. On and on until there's no more bytes that we can remove. We've exhausted the minimization, and to achieve maximum minimization. That's the point. I want to mention too, the Conto app also can give you some visibility into the target application. So in this one, for example, if we're fuzzing the SIPs app, you can open the Conto app, start streaming, and you can see the different messages that the application is putting out to, that you can view. So the Conto app's pretty handy too if you want to get more information about what's going on during fuzzing. So, fuzzing network clients. So, a couple examples here, SMB util and cups. Essentially, you just capture a PCAP, you export the bytes for each request, or in this case, for each response from a valid server, and then you pass them to LightFuzz to fuzz it. So for this one, we're using local client mode. That way we can launch each one and check for crashes. Pass a command line. We're trying to view, use SMB util to view at 4455. We're using 4455 because that is the address of our fuzzing server. We don't want to interfere with 445, which is the actual real SMB server running on the host. Throw in our responses. -P is just saying we're doing a session, so we have more than one input. We want to use everything that's in SMB response directory and use that as a session sequentially. So in that directory, we have like 1.bin, 2.bin, 3.bin, and it will play each one of those in order and randomly pick one to fuzz and all that stuff. And then -Z here. Oh, sorry, I didn't explain -C before with EZ. So -E reuses the crashes if it finds any. -Z it enables malloc debugging, so it enables the guard malloc to check for more subtle crashes. So I just like to put EZ together because it sounds like easy, and that's why. And then with cups, we can use lp-admin, check for different bugs in it, for example. Again, we change the port to make sure that we don't conflict with the real cup server on port 631. Essentially we're pretending to be a malicious cup server to fuzz lp-admin client. As far as servers goes, We have a couple here and probably one more. So we have the ARD agent, which is a VNC-ish type server. We have screen share daemon, which is actually a VNC server. You can read more about ARD agent if you search for it online about how it works. Pretty interesting. How Apple modified that and sort of came up with something for a solution for different VNC stuff. Essentially the same thing as clients: capture the data, export it, and then use it to fuzz. So if we look at ARD agent, we can see that it's listening UDP 3283. Also, it's suid root, which was also interesting in this. So that's an interesting fact when looking at it to see what kind of privileges it may be running at. With Light Fuzz, we can, instead of doing it as a local server mode with a command, we're just going to do it in remote mode. So just -s. We're going to specify the address there, and then the particular packet. Because in this one, we don't want to do a session. We just want to do the initial packet that was captured for this. And catching crashes can be interesting for this. You can enable report crash, as we mentioned before, and monitor the diagnostic logs for stuff. You can, you can implement other things. If you can get ARD agent running in a debugger, of course, then you can, attach and send a signal when it crashes, things like that. And then if we use dtrace to look at receive, we can see that while we're fuzzing, you can check to make sure that ARD agent is actually receiving messages and, fuzzing is going good and things like that. Screen share daemon, we're looking at port 5900. And then for this and other processes on Mac, launchd actually runs them only upon connection. So if you didn't have a connection, you may just see that launchd was just listening, but once you just connect to it, it will actually start the screen share D. Other apps work that way too. So it's something to know as well when you're doing research. And for this one, pretty straightforward, similar to the client side, except we're doing server. So again, we're doing remote server and passing that along. And then there was a remote. So this is so you can also use report crash. So we mentioned report crash before. There's a feature in Light Fuzz where we can specify a process that we're looking for that would be logged for crashes. And in this way, we can turn on report crash. We can fuzz. We can say remote mode, but still fuzz locally because we want to utilize report crash. And if there's any crashes that occur in the report crash directory, it will save them. And so at least we get some kind of crash log and of course the repro to go along with that. So there was a potential bug there. It wasn't really reproducible, but there was a CPU resource exhaustion log that was found for that, which was you can know that the fuzzing is working, at least if nothing else. And then we have ODS agent. So ODS agent is another example we're going to use here. It's an XML-based web service. Essentially, you can use it to share CD and DVD type stuff across the network. And the default is to prompt on request for access. So you can see here, just want to give an example of if you want to throw some format string specifiers in there. It seems pretty timely with the Wi-Fi stuff going on with Apple. So you can, when you're fuzzing that, make them across to prompt because it's just asking if the remote person can have access to it. Of course, that can be turned off as well. So for fuzzing this, it actually has a dynamic port, so you got to figure out which one that is. But we're going with 56156 today. And then give it the input files, tell it to fuzz a session. There may be 2 or 3 packets in the session. And then again, use -- report crash to look for crashes that involve ODS agent. And I have a bonus one today. So there's the Say app, which, if you're familiar, will read text files and things like that and say them through the speakers on Mac. So, I thought, what the heck? Let's try that. Pass the file through, let it read it. And I thought I would fuzz that just to see if, funnily enough, if there was any bugs. Haven't found any yet, but you may want to mute your MacBook if you try this at home. Here's what it sounds like. Yeah, so I was just curious if it's actually possible to crash this thing, but just got a bunch of, bad text output from that when I was looking at it. Anyways, just a bonus there, fuzzing the Say app on Mac and listening to it try to pronounce fuzz text. So some of the bugs actually came out of this that I can mention right now. AppleScript, color sync, syslog. There's some more upcoming CVEs, TBD as well for different stuff. There was some interesting bugs that came out of this, and sure Apple will have advisories and stuff for that later on. So for conclusion, maybe you're more interested in fuzzing on Mac now. Hopefully there's, lowered the bar as far as that goes. I haven't, going into this project, again, I didn't know much about Mac. I just learned a lot just going and doing it, trying to figure out converting a lot of the Linux type knowledge to Mac, GDB versus LLDB, and how to do, various activities on Mac, and how, I was curious if any of this stuff would actually work the same way, but there's actually a lot of crossover between Linux and Mac for fuzzing, which made things a lot easier as well. There's some, you need to work around certain things, turn some security features off if you want to, use it as a test box. But there's also a lot of good tools out there. dtrace was a great tool to use for this. Mac itself has some interesting tools to give you visibility. There's some more frameworks out there, such as Hookcase, that can give you some more visibility and things as well. And applying some unconventional techniques in fuzzing, you can still get some good results. So still shake some bugs out. So that is the end. Thank you very much for listening. Appreciate it.